Okay, problem number 5. I want to sketch the graph of the inverse function of whatever this function is. I'm not given the function, but I want to sketch a graph of the inverse. Well, we know by now that to get the inverse function, all we have to do is swap our x and y values, which is the same as saying we need to reflect this graph across the line y equals x. So first, I'm going to sketch in that line y equals x. It should look something like that, and now I need to go ahead and reflect this entire graph over that line. Now I found that the easiest way to do that is to actually rotate your paper so that you take that line y equals x and make it vertical. So rotate your paper until it's going straight up and down like that. Now we can just look at it and mirror the image across. So if we look at this first part right over here, I need to perfectly mirror that line across that line y equals x. So to do that, it's just going to go out like that, going on. Now let's look at the next part. Next part of the graph curves down like that. And notice it looks like I have a y-intercept somewhere, I'm sorry, an x-intercept right around 2, and a y-intercept right around 1, 2, 3, 4. So those points are going to translate as well, since that first point right there is the point 2, 0. That is going to translate to the point 0, 2, which is right there on my graph. The next point right there, my y-intercept, we said was the point 0, 4. So that is going to go to 4, 0, negative 4. So that's going to go to negative 4, 0. So 1, 2, 3, negative 4 right there. And now I can draw my line in, knowing that that is fairly accurate representation of what's going on so far. Keep going, look at the next part. And again, note that in our original function, we have an x-intercept right around negative 2 there. So in our inverse function, we're going to need to have a y-intercept right around negative 2 right there. So we would draw our line in. And then finally look at the last portion of our function, which just shoots off like that. So this is going to continue off just like that. Now, you may notice that this looks kind of goofy. The reason for that is because the axes on our calculators are actually rectangular. And you'll see this is actually just a graph from a calculator. So if it were a square window instead of a rectangular window, it would look like a perfect reflection. You would have your graph going like that, and this would be just like that. And y equals x would go right down the middle, and it would look awesome. But since that axis is skewed, we do not see that. But it works anyways, and wow. You should end up with something that looks a lot like that. Again, it's not perfect because of that skew there with it being a rectangular window, but it looks okay. Now going on to question number 7, asking if either of these are functions. Well, remember we have the vertical line test to tell if something is a function or not. So if you look at our original function in red there, we can see that that will pass the vertical line test. Anywhere we throw a vertical line in there, it only touches our function once. But looks like our inverse does not pass the vertical line test because each of those lines crosses our function twice, and so the inverse of this cannot be a function. Hopefully you are making the connection that the red graph is some sort of parabola x squared, and then this pink graph is going to be a positive and negative square root function of some sort.